Your API worked yesterday. Today it returns a different JSON shape, deprecated 3 parameters, and quietly renamed the endpoint. And somewhere in your agent framework, everything downstream just silently broke. If you've ever spent an afternoon hunting a tool failure that had nothing to do with your logic and everything to do with a vendor's changelog, you already know the real enemy here isn't the model. It's the churn. So let's talk about how LangChain and CrewAI actually handle tools when the ground keeps shifting beneath them, because they take genuinely different philosophies, and that difference decides how much pain you inherit 6 months from now. LangChain treats a tool as a first-class, tightly specified object. You define it with a name, a description, and a schema, usually through a pedantic model or the @tool decorator. That schema is powerful because the LLM reads it to decide arguments, and it validates inputs before they ever hit your function. But here's the catch. When your API changes, that schema is now a liability. If a payment provider adds a required idempotency_key field, your pedantic model doesn't know. So your agent confidently calls the endpoint with the old signature and gets a 400. The framework did exactly what you told it. The problem is what you told it is now a lie. CrewAI leans harder into structured tools too, especially with its base tool class and the args schema pattern, but its agent and task abstraction changes the failure surface. Because CrewAI orchestrates agents around roles and goals, a broken tool doesn't just throw an error into your code path. It can derail an entire multi-step crew. An agent that can't fetch data will often improvise, hallucinate a result, and hand it to the next agent as if it were real. So a small API rename becomes a plausible-looking wrong answer 3 steps later, which is far more dangerous than a loud exception. Now, the practical defense is the same idea in both frameworks, just implemented differently. Put an adapter layer between your agent and the actual API. Never let LangChain or CrewAI call a vendor SDK directly. Wrap it in LangChain. That means your tool function calls an internal client you control, and that client normalizes the response into a stable contract your agent depends on. When the vendor changes their shape, you fix one adapter, not 14 tool definitions scattered across your codebase. The schema the LLM sees stays constant even while the world underneath it changes. CrewAI benefits from the exact same pattern, but you also need guardrails at the task level. Add validation, so a tool that returns an unexpected structure raises loudly instead of returning garbage. Use CrewAI's ability to define expected output formats on tasks, and consider a verification agent whose entire job is to sanity check tool results before they propagate. The goal is to convert silent, plausible failures into fast, obvious ones, because a crash pipeline is cheap and a confidently wrong pipeline is expensive. Versioning is the other half of the story. Pin your dependencies, absolutely, but also pin your assumptions about the API by writing contract tests. A tiny nightly test that actually calls the endpoint and asserts the response shape will catch a breaking change before your users do. LangChain and CrewAI won't do this for you, and neither will beat the other on this front, because integration stability lives outside the framework entirely. It lives in your engineering discipline. So which one wins? If your workflow is a single agent making tool calls, LangChain's explicit schemas give you tighter control and clearer errors. If you're orchestrating a team of agents, CrewAI is more expressive but demands stronger validation to stop failures from cascading. Either way, the framework is not your safety net. Your adapter layer, your contract tests, and your loud failures are. Build those, and changing APIs become a Tuesday, not a nightmare.